Hi, my dear NEET aspirants, IIT aspirants, and parents. Good morning to all. Yeah, this is Mr. BHANU MOORTHY SHARMA, Senior Physics Lecturer, Senior Physics Faculty Member in Hyderabad, having 28 years of teaching experience in physics. Yeah, this is, please welcome to BMS Academy of Physics, NEET and IIT-JEE Entrance Coaching Center, which is established in Hariharapuram Colony, BND Nagar, VANASTHALIPURAM. Please welcome to this academy. My dear students and parents, on 15th August 2022, I projected one introduction video class. I have given detailed information about myself and my institution of physics. I also projected one free video conceptual coaching class. Okay, my dear students and parents, you go through YouTube channel and search this academy name, my name, then you can observe all the videos from me. Okay, thank you very much. And thanks to YouTube channel, this is the best communication channel between the best tutorial master in physics and students. My dear NEET aspirants and IIT aspirants, I given detailed information in video class on 15th August 2022. Now, I already released one video class 1 based on conceptual oriented. My coaching is entirely conceptual oriented. Okay. Now, welcome to this video class number 2. Okay. If you like all these videos, actually, I have to give 5 video classes to you. One is over. Now, this is the second one. If you like these videos, you please like, share, and subscribe. Right? So, my dear students, let us quickly start video class number 2. In first video class, different equilibriums I explained. Number 1, what type of equilibrium I explained in the first video class? Static equilibrium. And one concept on dynamic equilibrium, rotational dynamic. Now, in this video class number 2, I wanted to present rotational dynamic equilibrium and rotational static equilibrium. Okay, this is concept number 1. First one I am releasing. One uniform rod I am taking of length L, mass M. Total mass is concentrated at the center, geometric center of the rod. This is F1 equals to mg. The m is the mass of the rod and L is total length of the rod. Okay, this is a thick uniform rod. Now it is just gently placed on a fulcrum. This is called as a fulcrum. Okay, now this rod is placed pivoted on a fulcrum. Point 12. The rod is just placed on the fulcrum. Okay, it is tilting on the fulcrum. It is pivoted on the gently placed on the fulcrum. Okay, you can observe just gently placed on the fulcrum. Okay, about this point, the rod is rotating like this, tilting like this, right side, left side, like this. So the point O is called as tilting point. Okay, pivoted point, suspended point, tilting point. About that point, the rod is oscillating, rotating like this. So what we consider in this case? A thick uniform rod of length L, mass M, okay, which is concentrated at the center of mass, so that total weight of the rod is acting downwards. Now it is placed over the fulcrum, point O, called as tilting point. Now our assumption is a load is attached one side, left side of the fulcrum, a small load is attached. This force is nothing but F equals to small m into g, because its mass is small m. Okay, a mass small m is attached to the rod to the left side of the fulcrum, because if there is no mass attached here, what happens? The entire system tilts right side. Because major weight is this side, right side, and smaller weight is left side of the fulcrum. So the rod is right side. But our aim is to keep the rod in equilibrium position. In horizontal position, the rod should not tilt. What to do? Some weight is to be suspended or placed at a particular position from left side, left end of the rod. That is capital A. Right end is capital B. So from end A of the rod, a small weight is to be attached at a particular position. Now in examination, what they will ask, what is the position of the suspended load? So this position we are assuming it as Y. This is the question. And fulcrum position we are assuming X from end A. And total weight of the rod is situated at L by 2. From all the measurements, so we are taking from left side end, okay, left side of the rod. From A to center of the rod is total weight is L by 2. From the end A to fulcrum point is X. From left side end to this attached mass is at a distance Y. Okay, total mass of the rod is given, attached mass small m is given. The entire rod is pivoted on the fulcrum. Now the question is, in order to keep the middle rod in equilibrium position, what should be the position of this suspended weight? What should be the position of the suspended weight? So the entire rod is in equilibrium. It should not tilt right side. It should not tilt left side. It should be in horizontal position. What should you know? What concept it is? Equilibrium concept. Rotational static equilibrium concept. There are two forces acting on the first force is F1 equal to mg. And the position of this force from the point O, that is tilting point, is R1. So the moment of force R1 cross F1. This is called as moment of force. This force tries to take the rod in this direction. This is clockwise direction. So this is called as clockwise momentum. So clockwise moment it is. So clockwise torque Q1. This is equals to, okay. So clockwise torque it is. Another force F2 and position R2 from O, that is R2. So F2 R2 cross F2. This torque represents 2. Okay. So two torques are acting here. This force tries to tilt the rod in clockwise orientation, and this force tries to tilt the rod in anti-clockwise direction. So there exist two torques, two moments of forces. So when the rod is in equilibrium position, these two torques are equal in magnitude. Now I am equating magnitudes of these two. So R1 F1 equals to R2 F2. Right? Magnitudes I am considering. Okay. R1 means what here? R1 means dimensions are given there, measurements given. R1 is nothing but L by 2 minus X. L by 2 minus X. F1 means capital G is equals to R2 means what? X minus Y. That is R2. So X minus Y into F2 means small m g. G gets cancelled. From this relation, my dear students, if length is given as, say for example, some value is given, small mass is given, capital M is given, okay, everything is given, position, X also is given, position of the fulcrum is given in centimeters, then you can find out Y. From this relation, we can find out Y. My dear students, NEET aspirants and IIT aspirants, this type of question comes in examination, entrance examination. Then you have to observe this concept. So, clockwise orientation torque equals to anti-clockwise. Both are in magnitude equal. Okay, if they are equal in magnitude and opposite in direction, they cancel each other. As a result, net torque is G. This is rotational static equilibrium. If net torque is 0, net force is 0, net torque is 0, then the rod remains in equilibrium position. I think everybody understood this. So with this, this is my way of teaching now. So I think I am helping indirectly to junior lecturers also. Those who are eagerly waiting for my classes. I think I know that. So even junior lecturers are also waiting for my classes, the pronunciation, the vocabulary, and how to the way of teaching. Okay, they have to. I hope that I wish them to be success in their development. Okay, so they have to promote. Okay, with my lectures. Indirectly, I am helping to junior lecturers also, those who are going to give the classes to the students in their respective colleges. Right? Okay, my dear students, I am going to project second concept in this rotational dynamics only. I will explain today. Right? Quickly, let us go to concept number 2. In the second concept, my dear students, I am explaining rotational dynamics equilibrium only. Now this time I am suspending the rod on the fulcrum, but the fulcrum position is at the center. Okay, total mass is concentrated at the center, and fulcrum is placed at the center. Okay. This is NDA, this is NB. Total mass is capital M, total length is L. But the entire rod is placed on the fulcrum, which is at the center, geometric center of the rod. Okay. Initially, in the previous concept, the fulcrum was here. Okay. Now the fulcrum is exactly at the middle. Now, two loads I am putting on either side of the fulcrum. Two loads. Here I am putting load, some load M1G, that is F1, and here I'm putting M2G. The different positions I'm putting now, okay? And different positions I'm putting the loads. So this is F2 equals to M2G. Two loads I'm putting there, okay? Different magnitudes at different positions from this end A, right? Okay, now first force is at situated at a distance R1. Second force is at R2, right? Positions. Always we should measure the positions of the two forces from fulcrum, from tilting point. Okay, that is with respect to tilting point, we have to measure the dimensions R1, R2, right? Now, total fulcrum position L by 2, right? Fulcrum position L by 2. And first load position is X, let us assume. And second load position is Y. They are asking this one. Okay, at what position the second load should be placed so that the system remains in equilibrium? At what position the second load should be placed? Because if it is variable, as it varies, the system may not be in equilibrium. At a particular position of the first load, okay, this is why at this position the rod remains in equilibrium position. Okay, no? This is the concept. Now, in this case also, torque tau1 equals to tau2. So, this force tries to tilt the rod in clockwise direction. So, tau1 equals to R1 bar cross F1 bar in vector notation, right? And this force tries to tilt the system rod in this direction. Tau2 bar equals to R2 bar cross F2 bar. In vector notation, we are representing like this, okay? So, magnitude and diameter. But we are equating only magnitudes now for calculation. So tau1 equals to tau2, but here dimensions are changed. R1 F1 equals to R2 F2. So what is R1 here, my dear students? This is X minus L by 2. So dimensions are changing now, measurements are changed. So X minus L by 2 you can do. Okay. And F1 is M1G. This is equals to 2. You can put R2 F2 also, right? Okay. What is R2 here? R2 is nothing but from here to here. Okay. That is L by 2 minus Y. L by 2 minus Y into F2 means what? M2G. We can select M2G. My dear students, NEET aspirants and IIT aspirants, this is the method to calculate the position of the second load at which the rod remains in equilibrium position, right? So we can calculate y. So if y is given, x you can calculate position of the first load. If position of the first load is given, position of the second load you can calculate. Whatever it may be, right? Condition for equilibrium, tau 1 equals to 2. This is the method of explanation, my dear NEET students and IIT students. Okay, and parents also, and junior lecturers also, those who are going to promote in their classes, right? You have to get the appreciation by while be in front of your that is higher orders. So by listening my classes, right? My dear students, I am going to discuss third concept now, which is also rotational, dynamic equilibrium, static equilibrium, right? Because during a pandemic situation, the students are not able to listen the classes carefully. I'm not pointing out to the staff members. I'm pointing about the system now because due to pandemic situation, the students are not to colleges now. They cannot if they don't go to colleges and tutorials also. That's why I established my tutorial because of that reason only. For the sake of students only. So many parents and students requested me to establish this tutorial class. Okay, now in the early morning hours and in the evening hours only, I'm taking the classes. I'm not disturbing your college timings. Remember this point. Okay, so in the early morning hour from 4 to 7 and from 4 a.m. to 7 a.m. and the evening hours from 6:30 onwards to 10 o'clock, I'm taking 5 online batches now, NEET batches as well as IIT-JEE batches. Okay, because physics is a common subject to both batches. Okay, NEET as well as IIT. So, but difference is in IIT some integration problems they come. So we can explain integration problems after finishing the chapter. Let me take some additional classes today. And I will present all those integration problems today. But remaining all are common to both NEET batches as well as IIT batches, right? Differentiation is there, but integration problems to NEET students it's not preferable actually. So my additional information will be given to the IIT students integration point of view. That is different, right? Okay. Third concept is I'm selecting one metal ball. Okay. So practical experience I'm doing now with the practical article now I selected. This is a metal ball I'm selecting. I'm drawing one metal ball like this. This is the metal ball. I'm placing on the lowest step. I'm placing on the lowest step. This is the metal ball I selected. Okay. Should be exactly spherical in shape. Right. This metal ball is having mass m. It is resting on the lowest step like this. It is resting on the lowest step. Resting on the lowest step like this. My dear students, a metal ball of mass m. So mass m means its gravitational force will be downwards. No, F1 equals to mg. Immediately you can frame this force. A metal ball of mass m is on the lowest. Okay. Now its radius is R. I'm selecting capital R, radius. Okay. Mass is given, radius of the ball is given. It is resting on the lowest step of height. The lowest step height is given. Each step height is given. That is B. Right. Now, or H also you can take. Generally, H you can take. No height of each step. Now, our aim is to roll the ball. Our aim is to tilt the ball, roll the ball onto the upper step. What to do? Some external force is required. Some external force is required on the ball. So that force should be horizontal because you take a thread, a rope, you tie it to this ball and put it in this direction. This is a minimum force. What should be the minimum force required? The minimum force, horizontal force is required because we are pulling the rod, putting the ball onto the upper step with the help of a rope or thread. Some persons are pulling the rope in this direction because if it is a heavy mass. So This horizontal minimum force is required. What minimum force is required to just to roll the ball? You see, this is the best example. This is the ball. For example, let us say now it is tilting. It is tilting onto the upper step, rolling onto the upper step. Just to tilt, just to roll like this, just to roll. So this is called as tilting point. Okay, I think you understood this, everybody. So O is a tilting point about which the ball is rolling. The ball is tilted just to tilt, just to tilt, just to rotate, just to roll onto the upper step. How much minimum force is required? That is a question. My dear students, it's a tough concept actually in physics. In rotational dynamics, it's a tough concept. Because clockwise torque, anti-clockwise. The concept is simple, but the students cannot understand. What can we do? Okay, so my way of approachment is I will observe the psychology of the students now. I will come down to the students' level and I will explain. Whether they are understanding the concepts or not, I will observe each and everything. After that, according to them, I will explain it. If you have any doubt, I will explain. Right? But finally, you should understand the concept. While understanding the concepts, even 20 problems if you solve, you will be satisfied a lot. But without knowing the concepts, then even 1,000 problems also given to you, waste it is. That is my motto. Okay, now? So every day I am giving drilling class for 5 minutes. So what were the topics we discussed in the last class? Day before yesterday, what we discussed. So we can discuss all those fundamentals concepts within 5 minutes. That is the most valuable information that I'm giving to the students in the first 5 minutes. Drilling class, drilling with time. After 5 minutes, we will proceed to the further topics. Okay. Now, so this ball is rolling. Just to tilt the ball onto the upper step, what should be the minimum force required? That is a question. Just means what? Minimum means what? Equilibrium. Just equilibrium. Just about to tilt. Just slipping. Such type of words are given in the problem. You have to understand that the forces are equal. Equilibrium concept. Right? So, two forces are there. One is F1, another is F minimum. Now, from force F1, this is tilting point, we can take the measurements from tilting point, you know. Okay. So, from tilting point to this one. So, this is R1. Tilting point to this one, arrow mark I am putting R1. R1 cross F1. This is anti-clockwise. Okay. This force tries to keep the ball on the slower step only. Okay. So, this is 2-1 equals to R1 bar cross F1 bar. Okay, this is what type of orientation? Anti-clockwise. This is anti-clockwise moment of force, that is torque. And this force, and this is a distance. This is the distance, R2. From tilting point to the force, R2, position of the second force, from tilting point. Okay, R2. R2 bar plus F2 bar. So this is clockwise. So 2 bar equals to R2 bar cross F minimum bar. That's all. So my dear students, tau 1 equals to tau 2. Balancing condition. Just means what I told. Just about to, just to means what is that? Equilibrium condition. So tau 1 equals to R1 F1 equals to R2 into F minimum. My students, he is asking minimum force required. R1, come on, tell me. Dimensions are very important here. Geometry, okay. Pythagoras theorem, dimensions. This is h, this is h, and it becomes r minus h. Okay, I think you know that. And r2 also r minus h because opposite sides equal. Now let us substitute the values. R1, R2, we got it. R1 equals to square root of r square plus minus d square. So square root of r square minus this one's minus hypotenuse. It is Pythagoras theorem, right angle triangle. So r square minus r minus h whole square. Okay, this side I want right angle triangle. I think you understood. So into F1 means M1 mg because mass of the ball is given. Okay. is equals to R2 value by R minus H. We can put into F minimum. So my dear students, all values are given. Mass of the ball is given. Radius of the ball is given. Okay. Next, height of the step is given. Small g value is given. If all these values are given to you, you can find out what is that? F minimum horizontal force. Calculation everybody can do, by my dear students. Calculation everybody can do. Multiplication, divisions, additions, subtractions, everybody can do. But identifying the concept is very important. So this is dynamical equilibrium, rotational equilibrium. Okay, so clockwise torques, anti-clockwise torques, both are balancing each other. The ball neither move this side nor move this side, but in this question, just to rotate means it is nothing but equilibrium condition. Okay, what should the minimum force require just to roll the ball onto the upper step? Okay, my dear students, this is third concept I projected in this video class number 2. Right, now I want to project one more concept in this case, in fluids now. Okay, so this is the information I want to give to the students. So many students and parents requested me, so I established in the year 2019. Since then, it was running successfully now. Very good responses coming from students and parents. And some I given coaching from since 2018 onwards. So it was running successfully. So many students, boys and girls, got very good ranks in convenal quota. Remember this, in both NEET as well as IIT entrance. So with my coaching, they satisfied very well. Okay, that's the reason why good responses come. So they asked me, they advised me to give video classes, to project video classes. So that the students, maximum number of students can understand my way of teaching. Okay. The fourth concept I'm giving now. Fluid dynamics. Suppose this is water. Fluid means water, any liquid or gas, which is in floating state, right? This is a fluid. In a liquid now. A metal ball is dropped into the liquid. A metal ball is dropped into the liquid. Then it first enters, it comes very fast because of gravitational effect. Okay. Only gravitational effect will be there. It comes very fast. But after some time, what happens? Some resistances will be acted on the ball by the liquid. After some time. Okay. So during the journey, suppose the ball is here. It experiences three forces, my dear students. Listen carefully. Okay. So you have to observe this entire video up to the end, till the end, so that you can understand all the concepts, my dear students. So after listening up to end of this video, then if you like them, you share and subscribe. Okay. So this metal ball is having some mass. Mass of the metal ball is given. Say for example, 0.5 kg or 500 grams. So mass of the ball is given. Now it is coming down, gravitational force. It is external force. Remember this point. External force is gravitational force acting on the ball. So that is mg. But my students, what's happening now after some time? The liquid tries to oppose the motion of the ball. Because between the liquid layers, bonding takes place. Some interaction takes place. As the ball comes down, the liquid layers interact with each other. So due to that interaction, some friction releases. Okay. So that frictional force will be upward direction. So in friction chapter, in this chapter, fluid dynamics chapter, you can understand about frictional force and viscous force, everything. Okay. So this is viscous force. Viscous means friction. It's a type of friction. Okay. Interaction between the layers, liquid layers. Okay. That is frictional force we can call, or viscous force we can call. Okay, some liquids are thick liquids having more viscosity, some liquids are thin liquids, just like water, kerosene, like that. Their viscosity is less, like that. Okay, so viscous force between the layers takes place as the ball comes down. This friction opposes the motion. You know very well. Okay, after that, buoyancy force also is there. But first. So liquid is not willing to, is not allowing the ball to come down. Ball is trying to come down due to its own weight, but liquid is not allowing the ball to come down. It exerts some upward thrust. that upthrust is nothing but buoyancy force. Right? From these two forces, these two are internal forces, my dear students. Recognize this point. So these two are internal forces exerted by the liquid, okay, and they are opposing external force, gravitational force. So if these forces are equal and opposite, the ball may be at rest or may be in uniform motion. Okay, now in this case particularly, the ball moves instead of falling down quickly, instead of accelerating, now it is coming slowly with uniform velocity. My dear students, recognize this point. Even though external force is zero, even though acceleration is zero, the ball is coming down with uniform velocity. Okay, called terminal velocity. So what is the terminal velocity? That is the question in this concept. What is the uniform velocity? With what velocity the ball is coming down? Okay, that is the question. Now I am writing the concept. Gravitational force mg is balancing with some of the upward internal forces. So that is Fb, that is buoyancy force, plus viscous force, that is frictional force. So mg is 4/3 pi r into 4/3 pi. What is r here? Radius of the metal ball. Radius of the metal ball. So volume into density. Density of the ball is a d. I'm writing here. Okay. So into g is equals to what is Fb? Fb also same. What is that? 4/3 pi r volume and density of the liquid is exactly no. That's the density of the liquid you have to consider into g plus what viscous force. In that chapter, you can understand that formula. Now I am writing directly because it is a video class, free video class now. I am writing that formula directly. 6 pi eta r. 6 pi eta. Eta means n time. Okay, it is pulled down. So eta r into v. What is eta? Coefficient of viscosity. So what the liquidity is, we don't know. But liquid to liquid, eta value changes. Coefficient of viscosity. Okay. For thick liquids, eta value is more. For thin liquids, say like water, okay, eta value is less. Okay. For different liquids, coefficient of viscosity is different. Okay. Where r is the radius of the ball and v is the velocity of the ball. From this concept, we can calculate velocity. Velocity of the ball. Okay. So now I'm writing this side. Okay, count this side. What happens? 4/3 pi common. R cube also is taken common. T minus rho into G also common equals to 6 pi eta r e. What and what gets cancelled? So when r gets cancelled, square will be there here. 1 pi is cancelled, pi is cancelled, right? 6 2 3s goes, 2 2s goes here. Finally, viscous velocity, terminal velocity. V for terminal velocity, uniform velocity. Okay. So in equilibrium condition, the ball attains uniform velocity. Okay. Even though force is zero, net force is zero, net acceleration is zero, the ball comes down with uniform velocity. That velocity is terminal velocity. So they will ask that formula. Okay. Now, based on this formula, so types of questions they may ask now. We don't want to project all those points in this concept because it's a video class to you. Okay. So in the regular classes, we can discuss each and every concept. Okay. B is equals to 2/9 r square d minus rho into g by down. This is the formula. Using this formula, you can calculate terminal velocity of the ball. So my dear students, NEET aspirants as well as IIT-JEE aspirants. So most of the students, even they are studying NEET, but they don't know the full form of NEET. My dear students, for your kind information, I want to give that full form of NEET. Okay, do you know that? Okay, yeah, I want to tell you this one. So NEET means parents and students, please note down this full form of NEET without knowing the abbreviation, full form they are studying now by these students. NEET is the, what is that NEET? Come on, tell me. Are you late? Okay, National Eligibility Entrance Test. N for national, E for eligibility, next E for entrance, T for test. So national eligibility entrance test it is. It is MBBS entrance, for MBBS entrance it is, and BDS entrance. The students, BPC students, it is applicable for BPC students. Those who want to get MBBS seat, those who want to get BDS seat, okay, after intermediate, they can write this NEET entrance examination, okay, National Eligibility Entrance Test, okay. So my students, even students also don't know, maximum number of students don't know about the full form of IIT-JEE. I want to clarify that. If you give the chance to, okay, right. So IIT, what is that? Indian Institute of Technology. Indian Institute of Technology. Okay, Information Technology, Indian Institute of Technology. JEE means what? Joint Entrance Examination. It is not separate course for that, okay? It's entrance examination. Joint entrance examination. Okay. So, MPC students, those who want to get a seat in IIT, so many IIT institutions are there. Okay, nearly 17 to 20 IIT institutions are there throughout India. So to get a seat in those IIT institutions and triple IT institutions, okay, nearly some around from 70 to not exact 70 to 20,000 seats are there throughout India. Heavy competition is there. Some lakhs of students will write for this examination. Okay, they want to become IITs. So with the help of mains rank, that's why mains and advanced coaching centers will be there. So first they have to qualify in mains. Then after qualifying in mains, they have to write an advanced examination. You know, all those instructions will be given by the administrative members in the respective colleges. Non-teaching staff can give the information to you, because their duty is to give this information only, but they don't give. They don't know full form of IIT-JEE and full form of NEET. Without knowing anything, they are conducting the colleges. This is going on now actually. So I don't want to criticize them. So they are also conducting their institutions according to their boss decision, main boss in the state or in the entire country. From his instructions they are following, but they don't know about complete information about these two entrance examinations. How many seats are there in the entire India, throughout the country? How many seats are there? How many students are appearing in the examination? So entire information should be given by the non-teaching staff and administrative members in the respective colleges. And parents also should get awareness of all this, right? My dear students, this is my way of teaching, okay? Way of teaching. My coaching is entirely conceptual based, okay? Physics. So I am working, I was working in different corporate institutions for the past 28 years. I served a lot in my service. And after that, I got some injured to my legs. Then I can't move up and down, fourth floor to first floor to third floor. So they will play us with like football. So that is the reason why. So it is not their fault. I'm not criticizing them. It is very healthy person can go up and down, can run up and down. Okay, healthy person can become a wealthy. Okay. So I want to put the full stop after 28 years of teaching experience in NEET as well as IIT physics. Then on parents' request and students' request, I strongly decided to establish my own academy in my own building. This is now okay. So I'm free now. I'm a free bird now. I cannot go anywhere. Okay, I'm not going any institution. I'm not working in any institution. I have my own legs. I'm working on this in my own house. Okay, the students are coming and listening my classes. Even international level also, they are listening my online classes. My dear students, I am conducting online and offline classes. So you please like and share and subscribe these videos if you like, if you are interested, and contact these numbers, phone numbers. So I will be available from morning 9 to evening 4 o'clock, and from early morning and evening also I will be available, but I will be the classes. Okay, so better to not disturb, because my assistant will be there. They will give the complete information whenever you dial the phone to these numbers. Okay, get the maximum information to you. Bye students, this is second video class from me, BHANU MOORTHY Sharma, BMS Academy. This is okay. So third video class, I'm going to project very, very, very soon, right? Up to then, till then, wait. Bye-bye. See you.